Okay, participants, we'll start the session. Hello, good morning, good afternoon to one and all present here. Welcome to technical session 4A. Myself, Deepika Jain, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation, it is my great pleasure to welcome you to the 8th International Congress on Information and Communication Technology, ICICT 2023, London, UK. The 8th edition of this conference is being organized through an hybrid mode, and the physical event was held in London in UK, that is on 20th and 21st February. And the digital conference is being held through Zoom, that is on 22nd and 23rd February. I hope you will enjoy the knowledgeable sessions throughout the day. In this session, we have 6 presenters. Each presenter would be given 12 minutes for their presentation and 2 to 3 minutes for their question and answers. Okay, on 10 minutes, I would be raising a gentle reminder. So please take care about the time frame. Like we have parallel sessions as going on parallelly, so we have to be on time to avoid any delay. And there is another request for the participants to be in touch till the entire session. And if you have any query, you can drop me a text in the chat box. All right. And just before we get started, I want you to introduce to our session chairs. Just a moment. Gitanjali R. Shinde. And she has overall 15 years of teaching experience. She is presently working as an associate professor in Department of Computer Engineering at Vishwakarma Institute of Information Technology, Pune. She has presented a research article in World Wireless Research Forum meeting in China. She has published over 50 plus papers in national and international conferences and journals. She is the author and editor of 10 plus books. Her book, Data Analytics for Pandemics, a COVID-19 case study, is awarded Outstanding Book of the Year in 2020. I welcome you, ma'am. And we also have another session chair with us. That is... just a minute. Khaled Elberi. He has done his PhD in Management Information Systems, focusing on virtualization and cloud infrastructure engineering. He is working as visiting professor at few universities, teaching cloud infrastructure engineering, computer architecture and networking, wireless LTE, fiber optic technology, and voice and video transport. He was promoted many times. He held the positions of network administrator, network engineer, senior network engineer, principal network engineer, and currently serve as a senior director of wireless operation, designing, and engineering. I welcome you, sir. Sir, you would like to say anything about yourself? A quick 1 minute brief, if you want to, sir and ma'am. All right.
Hello.
Further.
Yes. Thank you for the introduction. I think we can start now.
Start with the presentation. All right. So we have our first presenter with us, that is Girish Sundaram. He would be presenting his paper on automating systematic literature reviews with natural language processing and text mining, a systematic literature review. Girish, can you hear me?
Yes, I can hear you.
Yeah, you can start sharing your screen.
All right.
Also, I request the participants to, rename their name which they had given us for the conference. Okay, so it would be easy for me to identify.
Can you see my screen?
Yes, I can see your screen and the voice is audible as well. You can start your presentation.
Okay. So in this presentation, I will be talking about the systematic literature review that I did, specifically with the intention of understanding whether NLP and text mining can be applied for the process of automation of an SLR, right? So what is an SLR? An SLR is essentially a well-defined, unbiased methodology to analyze all available evidence to solve a particular set of research questions. And there are wide-ranging applications of a systematic literature review. It could be applied for policy, decision making, or even in evidence-based medicine. The outcome of an SLR is considered to be of the highest quality because it sits on top of this pyramid that you see on the left-hand side. So it is the most robust way of identifying all available evidence and using that to come to a conclusion to answer a specific set of research questions. So in an SLR, there are around 12 steps. We followed the process of a systematic literature review defined by Kitchenham and others. So there are 12 steps. The first 4 steps are basically categorized under the tagger or the header of basically defining what an SLR should be doing. Steps number 5 to 9 is the process of actually conducting the review. It has different stages, such as defining the actual search criteria, defining the quality assessment criteria, data extraction, and data synthesis. The last 3 steps, 10 to 12, is documenting and reporting the outcome of the systematic literature review. The objective of my prior art search was to make sure that I collect all possible evidence that talks about application of text mining and AI, artificial intelligence techniques in the field specifically targeted for systematic literature review development. So we followed the Kitchenham process to define a set of evaluation questions. We also defined the search criteria, and we had a robust 2-stage screening process and applied quality assessment criteria and the framework to make sure that we are only considering the publications which is having the highest quality. So we defined what is the definition of high quality as part of this process. And then we were using a data extraction template to collect all the relevant information. And at the end of this process, we were left with a finalized list of 32 articles, which were most relevant to our specific research questions. So this flow shows you the entire process, starting from the initial stage wherein we had a list of 17,256 articles, which were part of the initial search results. But then, following the process that I had explained earlier, we came to a list of a final set of 32 articles, which were most relevant and of the highest quality. Okay, there are challenges, and there is a need for automation, specifically in the manner in which an SLR process basically is defined. I mean, everyone knows that scientific research and associated data is exponentially growing, and there are every article and every journal, the number of publications is growing exponentially. So, and also a lot of time is spent in actually publication and defining these processes, right? And it's also expensive, right? At the end of the day, whatever is getting published as part of a research article or also a systematic literature review becomes obsolete pretty quickly, because there is continuous advancement in this particular field, especially if it is in the field of evidence-based medicine. That is where my research is focused on, right? So it is kind of essential to make sure that we kind of automate and look at options to automate this entire process end to end. So these were the SLR questions that were the focus of my prior art analysis, focusing on which parts of SLR can be automated, what kind of TM techniques have been currently applied, what kind of models and algorithms have been applied, what kind of evaluation methodologies have been applied, and is there a tangible performance gain by employing TM techniques over manual process, and what are the open challenges and solution directions in this area. So these were the high level questions that we're trying to answer as part of my systematic literature review. This is a graphical representation of what I could find as part of this process. We found that most of the prior arts are concentrated on SLR 6, which is selection of primary studies, and SLR 8, which is data extraction from those individual studies. I think the reason why we found this to be kind of a skewed graph is because the first 4 stages are mostly process oriented, and the last 4 or 3 stages are mostly documentation purpose. So maybe application of TM and AI techniques may not be of significant help in those process, right? We also were able to find certain text mining models being kind of preferred over others. For example, SVM was a most frequently cited and most frequently used model and algorithm in this process, whereas others were not really that frequently used. From the technique perspective, we found that most of the research has been done for categorizing, which falls under the selection of primary studies, and the remaining TM techniques such as clustering, information extraction, information retrieval, and summarization have been inadequately represented in this existing research. Okay, this is the conclusion of the prior art search. We found that there has been NLP and TM techniques that have been applied in the area of automation of SLR, but their applicability in terms of really making a significant difference in fast tracking and adoption of those techniques in actual SLR development has been pretty limited. Okay. Important SLR activities such as literature string definition, literature search, and study quality assessment and data synthesis have been less researched and scrutinized, and majority of the research have been focused on either selection of primary studies, which is under the categorization section, or a very distinct second is the data extraction monitoring, which is also fairly more complicated, and that is the focus of my research. So SLR 8 is what I will be focusing on as part of my ongoing research. So these are this is the hypothesis and the research questions that I'm trying to solve right now. And I'm going to be focusing on evidence-based medicine because that is directly relates to my existing day job, and this is of area of interest to me. So I will be working on extraction of specific data elements in PICO, categorized as population, intervention, comparison, and outcome from free text search, free text documents. By free text, I'm referring to randomized controlled trial documents or SLR documents. And the second hypothesis is that data from these medical text corpus can be summarized to produce overall evidence, right? And the primary research questions is focused on generating an overall summarized evidence for a specific set of clinical question and categorizing that evidence as either weak, strong, or neutral. And then also conducting a research to see whether summarized evidence derived from an abstract, whether it is having the same efficacy as that which can be derived by summarizing the overall evidence from the full text search, right? So I will be comparing these two outcomes and then see whether we are able to get the same kind of outcome. Okay. As part of this research, I'm building an evidence-based medicine knowledge extraction and evidence summarization system. The one which is in darker color is something that is already existing. The lighter blue color is what is going to be the focus of my research. So I'm essentially trying to do an extraction of PICO elements at a much more granular level, and then using that process repetitively over a set of medical text corpus. I would use that for knowledge distillation and knowledge collection, and then use that for producing the overall summarized evidence for that particular clinical question. So I have given an example of how whether a Moderna vaccine has got any has got any risk if being given to a particular patient population, specifically those having diabetes and other metabolic risk factors compared to others who do not have these conditions. So this is just a sample. This is not kind of a suggestion that this is indeed true, but this is only given for sample purposes here. So the evidence basically suggests that based upon the initial observation that there is strong evidence that both non-diabetic and diabetic group have strong immune response to the mRNA vaccine, and immunity markers were observed to be lower in the diabetic group, which basically means that there might be some issues with people who have got certain preconditions or risk factors associated with diabetic. Maybe the Moderna vaccine is not really that effective. That's what the collection of these RCTs suggest, but that is not a conclusive evidence because we have not taken into consideration all possible evidence. This is just a sample of a few RCTs, but with the intention of just showing how the NLP application can actually help to summarize the evidence, right? In conclusion, I would like to talk about how do we advance the field of study. There are two gaps that were identified as part of the prior art search that we did. The first is pico extraction at an individual element level is not possible using the existing prior arts. So there is a definite gap there which can be addressed as part of my research. And currently, the pico classification is done for an entire statement and not for individual pico elements within a statement. The gap 2 that we identified was that the current prior arts do not have the capability to accurately summarize the overall evidence. So so that is a second gap that we are trying to address. And as part of my research, we would like to close these gaps and then provide more information on how this could be implemented and advance the field of study in this area. So that's pretty much it as part of my presentation for today. And I would be more than glad to answer any questions if there are any.
It was nice presentation, Girish. I would like to understand from which are the data sources for collecting the evidences as you are going to work on evidences.
Sure. Yeah. So I'm working on a set of 5,000 RCTs that have been annotated by Dr. Byron Wallace from Northeastern University, and these are available in the public domain. I'm also working closely with his team to understand how these were actually annotated by medical practitioners and pharmacists. In addition to that, I am developing my own set of corpus, which I am manually annotating with my committee members. One of them is a medical doctor, so he has got expertise in understanding and making sense out of RCTs, right? Randomized control trials. So I'm going to be using a collection of both of these repositories to actually train my models.
Okay. And is there any requirement of data pre-processing for your collected data?
Absolutely, yes. Yeah. So if you look at it from the data processing perspective, right? So you're looking at unstructured data. So we have to first of all parse the information from this unstructured text, tokenize them, and then categorize them as one of those 4 categories, the PICO categories, right? So there is a lot of pre-processing that has to be done. The problem the problem is that these tokens are, if you take these individual tokens by its on their own, right, they don't really make any sense. So there is a requirement to keep to preserve the context in which that particular token was actually used, right? So there is a need to have an intelligent model which can, while parsing the individual tokens, also understand the context in which that token was actually used in that statement, so that we can have a full understanding whether it falls under a specific PICO category or not.
Okay, it was a nice presentation. That's it from my side.
Thank you so much.
And no further question from my end. Good job.
Thank
Any
you.
questions from you, sir? Khalid, sir?
And no, good job. Thank you.
Thank you, doctor.
Okay. Yeah. So we have our next presenter. From Tokyo, on deep learning based arrhythmia detection using RR interval framed electrocardiogram cardiograms. I welcome you, sir. You can start sharing your screen.
Okay. Just hold on a second. All right, everybody can hear my presentation?
Yes, yes, I can.
Okay, good. Okay,
Please start.
okay. Hello everyone. Good afternoon in Macau. So nice meeting you guys. Today I'm gonna present it's deep learning based arrhythm detection using the RR interval framework for the ECG. So before I start, I would like to introduce myself. My name is Aman Kim. Right now, I'm the associate professor in Macau Polytech. Before I joined the Macau Polytech, I used to be working at a small, tiny company called Samsung, and then 10 years experience for the university or academe, and multicultural experiences. Yeah, as you can see my face, I'm coming from Korea, and then has been US like 4 years, Philippines 4 years, UAE kind of 6+ years. Now I'm in the Macau around 3 years. And then I was, my background is a little bit strange because my bachelor degree is physics, but my master degree is computer engineering, and then my PhD degree in the operations research. So my research area is kind of diverse. And then the biometric security or biometric authentication or biometric detection by using the machine learning is kind of one of my area. So, and then I'm joining the, and then I was used to be an associate professor for the other university in the all around the world. And then I'm coming back to Asian since 2019. So here is the agenda. Today I'm going to explain about the background of this research, and then bring up some kind of interesting prep process for adapting the machine learning techniques. And then actually this is one of the main topics in terms of handling the data. So I recently tried to building up some sort of compact, some sort of a new concept of data, and then it's kind of designing of data. And then this research is one of application or the one of examples to using the so-called compact data. So that kind of things I'm going to explain during the presentation, and then will be the summary, and the future research will be as a conclusion. So yeah, some of you already know about what is ECG. So ECG is basically the heartbeat, and then they have a bunch of studies to analyzing the ECG in terms of various way. Number one will be of course, detecting the disease, and then like what I did today. But one of the recent my research, actually, I tried to use. I mean, my colleague tried to use the ECG for the authentication purposes. So that is a variety of way of using this. And then before machine learning becomes very popular, still the ECG signal is kind of hard to handling them because it's a lot of variations and noises and so forth. But now these days, a lot of researchers in not only in the medical side, but also electrical engineering and computer engineering also involved in. So in terms of security, I mean, why I'm dealing with the security, because usually when you talk about the ECG, it is coming from here. So it's supposed to be coming from the hospitals and then huge equipment and so forth. But now these days, even your smartwatch can detect or can extract your ECG data. And then, having said that, you can have a lot of interesting things you can dig into. One of them is going to be the biometric authentication is one of them, and then it's kind of a self-detection of your heart disease or the abnormality of the heart. you can check this this is as a consumer level or as a personal level. So one of the interesting idea when I start this research is that in the side of medical engineering professors, once they talk about the ECG, they talk about this signal from here. And then for the electrical engineering or computer science side, when they talk about the ECG, they talk about the signal from here. So they have a slightly different gaps between them. And then for my research is more dedicated with the data from the like a smartwatch or the smart devices coming from rather than the heavy devices in the hospital. Although still we can use the same idea, similar technique into the from data from here, but that is main focus on our research now these days. So having said that, unfortunately, they don't have enough data to do those kind of research. So one of replacement is that we still need to use the ECG data from the public places, which is coming from the data coming from the hospital mostly. So that having said that, we're gonna have a certain prep process to make a signal more, either you may call it clearer or the more simpler. Okay. So because of that, they have several other noises typically come out from the ECG data from the hospital. One of them is going to be the this kind of the curve as a part of noise. So I developed some sort of prep process to handling those kind of noises. So that is one of them, and then the other one is going to be the let me show you. Yeah, like this, because in the particularly for the signal from the hospital, they usually have interference with the AC power. So as you can see, they have a lot of huge the noises in a particular frequencies. So I need to remove this also before we running the data into the machine learning. And then of course, sometimes you're gonna have a flipping signal because again, for the hospital, usually they use a couple of nodes together, unlike watch, because in case of you get a signal from the watch, it's very rare is the signal is flipped. But for the data from the hospital, usually they have those kind of flipping the data. So that kind of things we need to adjust them before we put this one into the machine learning training. So there are three typical prep process before we are doing this. So that is called the frequency changes, noise, notch filters, high noise filter. I believe some of you already major in the signal processing or the electrical engineering. These things is quite popular one. So that is a kind of general procedures for this. But the thing is that we've been using the new technique. It's called the time sliced technique particularly for the biometric securities. Why I'm keep talking about the biometric security is that usually when you're using the ECG signal for the hospital to detecting the certain disease or so, you need to take the ECG signal like at least 10 to 15 minutes, or usually sometimes they do 30-minute signals to do that, to analyze certain things. But for the security, I mean, you cannot stay in front of a building like 30 minutes to just simply enter the building by checking your ECG, right? So it should be shorter, like less than 30 seconds, or even 30 seconds is also big. It's supposed to be smaller than those values. So this new technique is called the time slice technique. Although we use the ECG signal, but we just use a small size of it. Like around, in case of security, you use like 15 seconds to 30 seconds. For case of disease detection, like this research, I use usually like a 30 second or the less than 1 minute signal. I use it, and the main idea is that the signal you have ECG. Is kind of you kind of slice them in a certain time slot. This one is a slice as a time slot. This one is making to the peak to peak. So that's why you remember my title of the paper is RR framed, right? So that's the RR meanings that the peak to peak. This is called the R peak. And then between the R peak, each time to the peak to peak, we slice the signal and then make the set of data. So that is actually making your, you're gonna have enough sample size for the training, although you gathering the data in a small portion, like less than a minute, but still we have enough data for doing that. So like this, you have a peak to the top, and then each time you slice them one to other, and then you're gonna have this kind of a signal. So, and then we're making the machine learning training based on this signal by itself. So basically, you dealing with a certain input as a part of images, and then is only have around the 200 point, and then using the CNN for the 10 layer CNN, and then it's basically determine whether this heartbeat is normal or this heartbeat more likely have a disease, arrhythmia.
Yeah, presenter.
Arrhythmia. Yes.
You have 2 minutes left.
Yes. Okay. So the long story short, so the accuracy is coming like 95%. So it's not that bad. Although the point is that it will be the smaller size of the ECG data, we still can detect it. Although it's a simplified output though, but that's how it goes. So currently what I'm doing right now, we only we kind of developing the certain techniques to minimizing the data, but that is enough to extracting the features, still containing the features like almost similar as 15-minute signals or the more longer signal. So that kind of tailor-made downsizing the data is one of the areas what I'm doing right now. And then recently I'm doing the more generalized version, because for the RRIF is a typical way of reducing the data, but it's a tailor-made. You cannot use same technique for the other machine learning data. But what I'm doing currently working on is called the CDL, the compact data learning, which is that I'm kind of making the generalized framework to reduce the data, but still good enough to containing the features of the data to training the machine. So that's what I usually doing, and then that will be going to be the kind of a future research of mine at this moment. I think that's it for now. Thank you very much.
Great presentation. Sorry for the background noise, as in my university events are going on. So it was the great presentation. Can you just explain more about the CNN architecture, like how many layers you are using, and
okay.
which type of input data? Is it from images, or what is the shape, and how you are working with CNN?
Yeah, so like I mean for the thing that my area is kind of applied machine learning rather than dig into the machine learning by itself. So the input is actually this peak to peak signal. So as you can see here, so you making as a one slice for the peak to peak, and then they layer to the around 1,000 slice signal you're gonna have. Then each signal, sliced signal, becomes to the input of the machine learning. And then in terms of the machine learning algorithm, I use a CNN, which is a package coming from I usually use the MATLAB. So they support to the, once you want to have a certain machine learning algorithm, just call the function call, and then they developing the, layers and so forth. So that part, because I use the other techniques, but the performance is not that much difference, because in terms of output, they are binary, the binary classification. So that is actually good and bad things. The good thing is that in case of a binary, you actually it's almost not. I'm not saying it's totally independent, but it's not much difference within the machine learning algorithm at all. And then it's very fast. But the issue is that you cannot making like 100 classification output and so forth. Then it's gonna be the you cannot use it as a simpler algorithm. But for my point is that not like focus on the algorithm by itself, but more like the framework, how we gonna rearrange in the input, and then how we gonna
Yes,
arrange in
yes.
the output and so forth.
Yeah, got it. So have you validated your framework by changing the size of data? Like, let's say
Yes.
first time you've taken few number of
Yes,
samples.
exactly. Yes, that's the whole point. But the idea is, originally the idea is that you should have good enough performance, right? If you reduce the data and then you sacrifice the accuracies, then there's no use, right? So my point is that how you gonna, although that's why I'm not called it the small size or downsizing the data, although I called it that way for the presentation, but I called it compact data because there is another research paper like 2 years back, how you gonna reduce certain types of data for dedicated with a particular application. For the ECG is one of them, and then there are the high frequency wave for the detecting the material. That is another research which kind of using the similar techniques to reduce the data, but that is a tailor-made. You should know the data or nature of data exactly. Otherwise, you cannot have a good performance for that. But as I said at the last page of my summary saying the CDL is called the compact data learning. I kind of constructing the general idea to either reduce the number of features or reduce the number of samples, but still have a similar similar, slightly lower or the similar performance like accuracies and so forth. So that is going to be the quite helpful for particularly if you are like you have limited resources. Like if you are working at the NVIDIA or if you are working at the Google's or Apple or the Microsoft, yeah, you have almost unlimited resources, right? But I mean,
Yes.
like me, I'm using just my computer and my desktop. I cannot have those kind of luxury, right? But if you somehow you can reduce or the compactizing those data, then you can even have a significant result even by using the Excel file. It's possible. So that kind of approach is what I'm doing right now. So
Okay. That's it from my side.
It's very promising. So
thank you very much.
for your time.
Yes, sir. The video is clear. I can see the video, but I cannot hear the audio.
Strange.
So better do one thing. You need to speak it by yourself. Explain the presentation by yourself.
Okay.
The audio is not.
Okay. Thanks.
Yes, please start.
So, greetings. My name is Leonid Debkach. I'm the postgraduate of the Bauman University and one of the authors of this research on the topic hybrid network anomaly detection based on weighted aggregation using endpoint parameters. We consider a hybrid approach to anomaly detection taking into account the parameters both of network itself and network endpoints. As you know, in recent years, the bulk transfer of enterprises employees to remote work from home, as well as informational confrontation, have led to the emergence of many problems related to data security in corporate networks and other spheres. Information security specialists need to monitor more different indicators to detect the problem. So the complex approach to detection of anomalies is important nowadays. First of all, we should choose the way to convert endpoint parameters to the format of the network parameters. There are two ways to do it based on manual search and regrouping by data type. We chose the second method because it is based on automated partitioning of the set of node parameters into subsets according to the parameter data type, as well as on the rules for converting parameters within these subsets into the session parameters format. On this screen, you can see our algorithm of converting the endpoint parameters to the format of the network parameters after dimensionality reduction of the network parameter space. For example, deletion of a file on a node can be represented as decreasing the size of the file with informational transmitting from the node's IP address in the form of the corresponding parameter values on this node. The deletion of a file occurs during the session when data is transferred from this node to another that helps to be processed by the protection tools on the node and can be recognized as an unauthorized data deletion in the context of the corresponding session. So this is the structure of the proposed hybrid system. To detect anomalies, ensembles of machine learning I used with the inputs receiving session parameters and network nodes. The signation analysis of the ICICT and Vazuh platform help to detect the known anomalies. The fusion of a classification result is based on weighted aggregation with anxiety threshold beta. As a weighting factor, adjusting the sensitivity of the terminal classifier to the nodal parameters. We checked the proposed approach using the virtual structure, which you can see on this screen. An experimental evaluation of the developed approach proved its advantages in comparison with the detection of anomalies without taking into account the endpoint parameters. The anxiety threshold was found empirically. We also should notice that enriching the input data with a viral tool provide the more complex view of the events in the protecting system than without them. So the experiment also showed possibilities of the proposed approach for extended detection and response. In the future, we are going to formalize the way to find a beta factor based on reputation, trust, and data quality metrics. We also consider to introduce the proposed approach into both current and future anomaly detection systems of the smart city or alternative Internet of Things services. But for now, I am over. Thank you for your attention. I am ready for your questions. That's all.
It was a nice presentation. I would like to know that for this Ansible learning, you have used the Ansible learning algorithm. Can you explain more about your dataset?
So we use one moment. And the ensembles, two ensembles of machine learning classifiers, which are logistic regression, stochastic gradient descent, and decision tree. We use so the copy of this triple ensemble for the network parameters and the nodal parameters for dividing the results for the next aggregation on the terminal classifier.
Okay. And about what are the pre-processing required for this before applying the ensemble learning? Or is the dataset was the ready for the implementation?
We made the virtual structure on this SIG IDS 2017 data set, and we're going to check the work on the real data in the nearest future.
Okay, so I mean to say that have you created the attacks or whether that data you already received for your implementation? And why you have chose in Ansible learning, why you have chose for the bagging approach Why not for the boosting one? Because that is also gives good results.
So we use a data set of normal events and attacks signatures. So we should check which signatures we can recognize using the signature analyzers. But we also should find more of them using the machine learning ensembles.
Okay. So it was nice presentation. Just my suggestion will be, as in ensemble learning, you are using different classifiers. So if you could add some explanation about each and every classifier, like for this classifier, why this your model is giving this result. For another classifier, why it is giving some this result. So if you can add this into your research, then that will be the great. So overall, nice presentation. That's it from my side.
Thank you. Thank you. Thank you so
Thank
much
you.
for the presentation. So we have our next presenter, Nidal Imam, who would be presenting a paper on towards an advisory aware ML based detector of spam on Twitter hashtags. I welcome you, sir. You can start sharing your screen.
Sure. Can you see the screen?
Yes, I can.
Thank you very much. Okay, hi everyone. The title of my paper is Towards an Adversary-Aware Machine Learning-Based Detector of Spam on Twitter Hashtags. So this work is part of my PhD thesis, and it was supervised by Dr. Vasilius and also Dr. Dimitrios. So my presentation is divided into 3 sections. First, I will give a brief introduction about the topic. I will talk about the background, motivations, and also the goals. And then I will talk about the proposed model, methodology, and experiments and results. And finally, I will conclude my presentation. So as you all know that spam is unsolicited or unwanted message, and usually spam are used to spread advertisement, but sometimes also spam are used to spread malware. And one of the examples is that a number of NatWest Bank customers were victims of a phishing attacks that was launched by spam messages on Twitter. So although spam can be found in all forms of online communications, such as emails or on the web, however, spam on online social networks or on Twitter attracted the attention of different researchers because it's much easier for spammers to spread their spam messages using some of the features of Twitter or other online social networks, such as the trending hashtags and shortened URLs. These kind of features or characteristics enables spammers or adversaries to spread their malicious messages more quicker. So also sometimes when the spam messages are controlled by a third party or a malicious party, they are called spam campaign. So these spam campaigns, they use different spamming techniques such as bots or hijack accounts. So now I'm going to talk about the motivation. So the first motivation for our research is that machine learning have been adapted to improve the detection or accuracy of detecting spam on Twitter or other online social networks. However, most of the studies that adapted machine learning models for detecting spam, they only focus on how to improve the prediction accuracy of these machine learning models. However, they always overlooked the security of the adapted machine learning-based models. So as you know that some recent research have proven or have shown that machine learning algorithms or deep learning algorithms are vulnerable to adversarial examples. So adversarial examples are input to machine learning or deep learning models designed to cause incorrect output. And these researchers categorize possible attacks against machine learning models into 2 categories. first, causative attacks, where the adversaries attack the model during the training stage and cause misclassification. And the second category is the exploratory attacks, where the adversaries attack the model before the testing time and cause misclassification. So this is our first motivation, is that most of the related studies or existing studies only focus on how to improve the prediction accuracy of the spam detectors, but they are always overlooked the security of the adapted machine learning algorithms or deep learning algorithms. And the second motivation is that in 2018, there were very active spam campaigns that spread untrustworthy healthcare advertisement in Arabic trending hashtags. And the question was why Twitter could not detect this kind of spam messages, although these kind of spam campaigns, they show very clear sign of being a spam. They send a lot of messages using private accounts. They use hijack accounts, but Twitter were not able to detect them efficiently. So this is our second motivation. How can we analyze these spam campaigns and try to find if there is any adversarial attacks or adversarial activities? So the main goal of our paper was to design adversary-aware machine learning-based detector of Twitter and trending hashtags, considering three key points. First, the robustness to adversarial examples, also the adaptability to detect and collect evidence of evolving adversarial attacks. And example is adversarial drift. And adversarial drift is one of the phenomenon that need to be considered when adapting the machine learning models in cybersecurity environment, because as the detection methods improving, also the adversaries tactics or methods evolve over time. So if we design the machine learning for a particular attack, the adversaries may change their tactics to try to avoid being detected. So the adaptability is how can the model detect and also collect evidence of evolving attack. And the third point is interpretability, and interpretability to enable the designer or the security analyst to predict and understand the output of machine models. Because as you know, that nowadays the interpretability of machine learning is a very hot topic, because using the deep learning algorithms are considered as black box models. It's hard for us as a human to sometimes to predict how the deep learning algorithms arrive with their prediction. So that's why here we try to design adversary-aware model that consider these three key points: robustness, adaptability, and interpretability. So the methodology that we follow, first, we try to identify possible attack, and then we try to evaluate the robustness of machine learning-based detector against the identified attack, and then to improve the robustness of the existing machine learning-based detectors. So first, to identify the possible attacks. So through observation, we, after studying the targeted spam campaigns, we found that these campaigns use unique accounts. They use hijack accounts that are old, and they have only a few number of messages in their timeline. So as you can see here, we have two accounts, and the first one was created in 2016, and the number of messages on this account is only 5 messages. So this is abnormal characteristics. And also the second account here was created in 2013, and it only consists of 4 messages. So these kind of characteristics, we consider it as adversarial examples. Why? Because as the account is getting older, the number of messages is supposed to increase. But here we have old accounts that have very few messages, especially for the accounts that are used for spreading advertisement. They tend to have large number of messages. So these kind of accounts were considered as adversarial examples because these kind of accounts can easily fool or overcome or bypass the existing machine learning based detectors. So after identifying this kind of adversarial examples, we created a new data set. The data set were annotated by different annotators, and then the data set was published. And then here we measure the correlation between the account age and the number of messages for the non-spam accounts and also for spam accounts. And the results show that there is a positive correlation between the two features for non-spam accounts, whereas there is a negative correlation between the two features for the spam accounts. So based on the results, we think that this kind of, or these two features can help distinguishing or improve the detection of the targeted spam campaigns. So then we start to create our adversary-aware machine learning detector, considering the three key points that I mentioned before. The robustness, here we created a new feature. We call it average number of posts. And also we publish a paper about this feature where we analyze the feature with more detail. And then we consider the second two key points, which are the adaptability and interpretability. Here we use a multiple classifier system with fuzzy rule-based classifier. So here we use four classifiers. We use first classifier to analyze the statistical feature of the Twitter messages, for example, number of accounts, number of friends. And also we use three textual-based features to analyze the content or the textual content of the messages. And then we use a fuzzy rule-based classifier for three reasons. First, to aggregate the result of the four classifiers. So most of the related studies, they use a deep learning algorithms for aggregation. However, as our goal is to make our model interpretable, we decide to use fuzzy rule-based classifier to make the model more understandable by the security analyst or the designer. And also the second point that the reason that we choose the fuzzy rule-based classifier is that to ensure the adaptability of our classifier. So here we consider the disagreement between the classifiers. So if the disagreement between the classifiers reach a threshold or a certain percent, then the security analysts need to investigate and maybe update the models. Also, if the detection accuracy of the classifiers dropped under the threshold, here also the security analyst will be notified and it will investigate and improve or update the model if it is necessary. And the third reason is to ensure the interpretability. The fuzzy rule-based classifier is more interpretable and understandable by us as a human. So for evaluation, we use different evaluation methods. First, we use the mean decrease accuracy methods to measure the importance of the new design feature to the deployed classifier, which is random forest. And the results show that the design feature has the greatest impact on the detection accuracy of random forest. And then also we evaluate the importance of the new feature using 6 supervised models. And first we evaluate the prediction accuracy of the models without using the design feature. And then we evaluate the prediction accuracy of the 6 supervised model using the design feature. And the results show that we were able to improve the detection by almost 10% for some of the supervised models. Also, we evaluate the importance of
Dear
the
presenter, you have 2 minutes left.
Sure, thank you very much. So also we evaluate the importance of the proposed feature to unsupervised classifiers, and also it shows that we were able to improve the prediction accuracy. Finally, we compare the detection accuracy of our model with 3 state-of-the-art classifiers, and the results show that we our algorithm, our detector outperform the 3 state-of-the-art classifiers. And finally, also we simulate how the model can handle the drift, adversarial drift. But because we are running out of time, I can't explain the simulation process. However, to conclude my presentation, we were able to identify a new adversarial attacks against machine learning-based detection of Twitter spam we created a new database and also dataset, and we published the dataset. After analyzing the dataset, we found that 13% of the bot account on our dataset were suspended by Twitter, whereas 40% of the hijack accounts on our dataset were not were unsuspended by Twitter. So this is show that detecting bots is much easier than detecting hijack accounts. And here also for future work, we would like to evaluate our detector against different adversarial attacks. Also, we would like to perform more experiments on handling adversarial drift. And also we would try to evaluate the interpretability of our model. So thank you for your attention, and I will be happy to take your questions.
It was great presentation.
Thank you.
I wanted to know, have you considered sarcasm? Like few people are sarcastically tweet. So have you considered this into your analysis?
Oh, actually, I haven't considered this because our focus was on a specific spam campaigns, and these spam campaigns are very clear. Or I mean, the campaign only advertise healthcare products, so we haven't considered any other type of spam.
Okay, thank you. Great presentation.
You're welcome. You're welcome.
That's
Thank
it
you very
from my
much.
side.
Thank you, Nidal, for the presentation.
You're welcome.
So we have come to the end of the session, and I sincerely thank our authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative to you all, and I would be happy to see you in the 9th version of the ICICT conference as well. All the presenters would be getting their digital certificates through email within 2 working days. And the papers have already been forwarded to the Springer board, and the publication would be live within 6 months. So please cooperate with the team of ICICT. I also thank our session chairs, Geetanjali Shinde and Khalid Elberi for chairing the session. This is from our side as a token of appreciation. Thank you so much, sir and ma'am, for your presence here. It was great to have you here. And I would request the participants, Asma.
Welcome to you. Can you hear me?
Joined? Okay, you have
Can
just
you hear?
joined.
Can you hear me? Okay.
Yeah, I can hear you. You just joined, right? Okay, I was about to close the session. All right, Asma, you can start with your presentation.
Thank you. In my presentation, I want to talk about hybrid method to analyze a skin tumor image and classification. And introduction, when we ask what is skin tumor? A skin tumor is an abnormal growth of skin cells that have been exposed or have not exposed to sunlight. It is one of the most worldwide diseases that causes death. There are 2 types of skin tumors, melanoma and non-melanoma. Therefore, early detection for these tumors may increase the curing rate to 90%. Challenges. One of the most important challenges that dermatologists suffer from the diagnosis is the similarity between the tumors, which makes the visual examination hard and may lead to the wrong investigation. However, we can solve this problem by overcome by taking image samples and analyzes them to reach high accuracy in the diagnosis. A standard data set from skin cancers from Harvard University, which has 10,015 images are used. Aim of this research. In this research, we need to reach high accuracy diagnostic system for skin tumors by analyzing medical images using different techniques. By analyzing the images structure, extract features, make decision, and provide result. Uses different types of transformation with first-order statistics and backpropagation in neural networks. The methodology. In this research, we propose the system that contains 3 levels. The first stage, image pre-processing, and the second, feature extractions, and the third level is a classification. We see in this part the image after the image acquisition, we need to pre-process for the image by hair removing and segmentation. After that, in the second stage, data reduction and feature extraction are used. Feature extraction, subblock DCT, and two-level discrete wavelet transform, and the first-order statistics that include mean, standard deviation, skewness, and kurtosis are used. After that, we need to send the feature vector to machine, to artificial neural network. In this research, I use backpropagation algorithm then for training and testing. In the stage of image pre-processing, we make noise removal. Here, unwanted pixels like hair are eliminated from red, green, blue images using medium filter. A cropping area of interest is the cancer region. By isolating the region of a tumor, the white space surrounding cancer have been cropped. Normalization, the RBG images are resized to 128 plus 100 multiply 128 pixels for cropping cancer region only. This flowchart explains the hair removing using the browser algorithm. In the diagram, the binarized segmentation operation, such as binarization, we used to isolate the tumor. I used 2 types of filter. After I examined more than filters, we used 5 and 17 filters to isolate the tumor to reach high accuracy isolation. And after that, resize the image. Feature extraction. 2 types of feature technique are used. The first is the first order statistics like mean, standard deviation, skewness, and kurtosis, and also use discrete wavelet transform and discrete cosine transform. This figure explains the discrete wavelet transform HAR type for 2 levels. This is the first level and this is the second level. These figures explain the discrete cosine transform. After that, I make subblock to the image to increase the accuracy. After that, I draw it in mesh method. My proposed method explained in this diagram. After read the skin image and pre-processing the tumor isolation, I use discrete wavelet transform HAR type 2 level with Michelson contrast and standard deviation. When I calculate these, I save it. I calculate the first order statistics, mean standard deviation, skewness, and kurtosis, and pass the feature vector to the artificial neural network. This graph explains the training operation using backpropagation in neural network. We reach to the accuracy of recognition to 94% for discrete wavelet transform. This diagram explains the discrete cosine transform and the subblock discrete cosine transform with Michelson contrast, and after that I calculate the first order statistics like mean standard deviation, skewness, and kurtosis, and pass the feature vector to the artificial neural network for training and testing. The accuracy reached when I used the discrete cosine transform 89%. But when I combine between the discrete cosine transform and discrete wavelet transform present in the following diagram, after pre-processing operation, I calculate the discrete cosine transform and subblock discrete cosine transform and discrete wavelet transform for two levels with Michelson contrast and standard deviation. All these features with mean standard deviation, skewness, kurtosis saved in a data file and saved in feature vector and passed to the artificial neural network. When I mix between these two features, I can reach to accuracy recognition to between 94 to 100% for 7 types of these diseases. Conclusion. In this search, we know that system also able to isolate the tumor area from the rest of the skin efficiently, especially since some types of tumors are close to the color of the normal skin, where the skin color of the woman is light. Working with the hybrid system by mixing more than one method help to obtain more accurate result when mixing discrete cosine transform with discrete wavelet transform. Thank you very much. If you have any question.
Nice presentation.
Thank you.
Can you explain more about the data set and means how many images you have taken? And is
Yes.
there have you done any data validation by taking different data sets for finding out the accuracy?
I used the data set 2018 because this more accurate and have more than images like 10,000 15 image, and I make on this type of image because is the doctor can diagnose it. But and other data like 2019 and 2020, but not accurate. This type of data set is more accurate.
Okay.
It has 7 types of diseases like basal cell and carcinoma and other type of diseases. 7 type of disease.
Okay, that's it from my side. Nice presentation.
Thank you.
Thank you. Thank you. Thank you so much. So, I sincerely thank our authors and presenters for the wonderful presentation. I repeat, all the presenters would be getting their certificates within 2 working days, and the publication it would be live within 6 months. So kindly cooperate with the team of ICICT. And also I thank our session chairs, Gitanjali Shinde and Khalid, for chairing the session. It was wonderful to have you here. Thank you, sir. Thank you, ma'am.
Thank you.
This is from our side view, a token of appreciation. I would request you all to switch on your camera for a quick snapshot, please. Thank you. Thank you so much. It was great to have all you heard here. Stay safe. Take care. Bye-bye.
Thank you.
Bye-bye. Thank you.
Thank you.
Thank you, everyone.
Yes, thank you.